I wanted to give an opportunity for you guys to get an in-person explanation of these because they are problems that they're just really important, in my opinion. Problems that come up all the time, and we need to be on the lookout for them. So there's just a couple of them that I want to explain. I would encourage you to try them first and just see how it goes. But the first one is an FRQ, question 1, and I want to look at B. Okay. Since it's question 1, on FRQs, 1 and 2 are always calculator active. So these are calculator active questions. So be ready for, Math 8, Math 9, being ready to use your calculator, things like that. So this question is a particle motion question. They don't give the particle's position. They give velocity, and then they give acceleration. Now, I know we haven't dealt with E and stuff like that yet, but since it's calculator active, we don't really need to know a lot about E because our calculator is going to do all the work. Okay, that's number 1. And if we look at A, I know we're not doing A, but I want to remind you about how to find speed, whether it's increasing or decreasing, because we did this first semester. If we're looking at speed increasing or decreasing at 5.5, well, we find velocity at 5.5. Just use our calculator, plug 5.5 in. Find acceleration at 5.5. And then remember, if they have the same sign, speed is increasing. If they have opposite signs, speed is decreasing. So I'm not going to go through that one, but I wanted to remind you. But B is the one I wanted to do. It says, find the average velocity of the particle for the time period 0 to 6. Now, there are 2 different average type questions you are going to be asked on the AP test. They might ask you to find average rate of change, and then they might just ask you to find the average value of something. If ever you see the phrase average rate of change, that is slope formula. If this question said, find the average rate of change of velocity, I would plug 0 and 6 into velocity, and I would do my y2 minus y1 over x2 minus x1. Since this just says find the average velocity, that means I'm doing the average value formula for velocity. The average value formula, which is one we're going to have to know, is 1 over b minus a times the integral from a to b. And then whatever you're finding the average value of, this is critical, and I can't say this enough. If you're finding the average velocity, you integrate velocity. You integrate whatever function you're finding the average value of. That's super important. And then I just plug in my stuff. So a and b are 0 and 6. So this would be 1 over 6. The integral from 0 to 6. And then here's the thing on FRQs. If they name functions, and actually you can name functions yourself, but if they name functions, you don't have to write this function in the integral in terms of getting your points. You can actually just put v of t inside the integral, and that's going to get you your setup point. Now, this is not the answer. We can't just leave this. But this would get you your point for setting up the problem. In fact, if I look at the rubric, if you look right here, you get 1 point for the integral, like you would get 1 point for this. And then we don't actually have to integrate by hand. This is a Math 9 question. So I would take out my calculator and I would do this integration in my calculator. So to refresh your memory, I would encourage you to, if you have a fraction out in front, I would encourage you to put that fraction first so you don't forget about it. I find a lot of students will do the integral intending on dividing by 6 at the end, and then they forget to divide by 6. That happens a lot. So I would encourage you to put the 1/6 first, then Math 9, or finint. If you want to scroll down, you could just push Math 9. And then I just enter the integral as I see it. So from 0 to 6. And then I do have to type in the velocity function, so 2 sine of e to the t over 4. So e to the, and then we just use x over 4. Close parentheses. And then plus 1 dx. 1.949. So we would just write, if this was me doing an FRQ, I would put equals 1.949. Remember, we have to go to 3 places. So make sure you're in radian mode. I would encourage you to enter this in the calculator, but we always in calculus need to make sure we're in radian mode. My point of doing this problem was if we're finding average whatever, that's our average value formula. If it says average rate of change, that's slope formula. That's not integration. Okay. The other one is one that I actually showed at the end of the notes last time, right here. It's using the second fundamental theorem of calculus. I put this up at the end of the notes, and I said, if you notice, they give the graph of f, but then all the questions they ask are all about g. Well, they love to name functions in terms of integrals of other functions. It kind of connects both semesters of calculus. So the very first thing I would do, when you see this problem, and you almost certainly will on an FRQ, this type of problem has been on FRQs most years. Not every year, but most years. So first thing I would do is differentiate both sides of this equation, because the left side would be g prime of x. And when you integrate the right side, remember all that happens is that x just pops right inside of here. And sometimes, some years, this is worth a point. Just writing this gets you a point. They want to see this equation. But my advice to you is I would go up to the graph, cross out f, and write g prime instead. Now, this is the whole graph of g prime, and we can answer all these questions just like we did first semester. So I'm going to go through A, B, and then I created another one, C. So it says, does G have a relative min, max, or neither at x equals 10? Well, remember, relative mins and maxes are where G prime crosses the x-axis. Not touches, but crosses. So right here at 10, since G prime is 0 and then it's negative and negative, this would be like your sign chart, negative, negative. There's not a min or a max. So I would say neither, because the sign of G prime doesn't change at x equals 10. So I'm not going to write that, but that's just a review from first semester. Does G have an inflection point at x equals 4? Well, remember, G has inflection points. There's two ways you could think about it. It has an inflection point when G double prime changes sign. But since we're not given G double prime, the other way to look at it, anytime G prime has a relative max or min, then G has an inflection point. Like G would have an inflection point here, because there's a maximum. It would have an inflection point here, here, here. All these like relative maxes and mins, G has inflection points. So I would say yes, because G prime has a relative maximum at x equals 4. Or you could say because G prime goes from increasing to decreasing at x equals 4. But if they give you the graph of G prime, they want you to use G prime in your justification. They don't want you to say because G double prime changes from positive to negative. You might get credit, but sometimes they don't. They want you to use G prime. None of that's really new, but I wanted to refresh your memories. The new one is C. So C says find G of 8. Now this is really important and kind of the reason why I'm doing this problem. Find G of 8. So if I look back at this original equation, okay, I know that I said step number 1 is write this, and we use this to answer a lot of the questions. We technically, a lot of times, are still going to use this equation to answer questions also. When they say find G of 8, well, imagine me plugging 8 in for x right here. Well, if I plug 8 in for x here, I also have to plug 8 in for x here. So here's what I would have. I would have G of 8 equals, and then the integral from 2 to 8 of f. Now, G of 8, whatever that is whatever this integral is. Remember what this integral is. The integral of f, which is what this is the graph of, from 2 to 8, is just saying what's the area under this curve from 2 to 8 of this graph. So we need to find the area from 2 to 8 over here. So we have to find the area of this triangle, and then of this triangle. And remember, when you're integrating from left to right, if it's positive, or above the x-axis, that's positive. Below the x-axis is negative. So I need to find the area of these triangles. So that first triangle would be 1/2. Let's see, the base is 4. The height is 4. So 1/2, 4 times 4. So 8. I don't like how I wrote that. I'm just going to put 8. And then the next triangle, since it's below the x-axis, we're subtracting. So 1/2 times 2 times 4. So 4. So negative 4. This area is 4, so we're going to take 4 away. And then that gives us g of 8 is 4. The reason, I mentioned how I would kind of explain why, if it's above the x-axis, the area is positive and below is negative. I'm going to explain now. So remember, when g prime is positive, when g prime is above the x-axis, which this graph is, that means g is increasing. We know that. We know that from first semester. G is increasing. Now that we know integration and area, not only do we know that g is increasing, but actually the area under that graph tells you how much g is increasing by. And that's when it gets really neat. We're now combining first semester and second semester calculus in one problem. Since g prime is positive, we know g is going up this whole time. G is increasing this whole time. And actually, this area tells you how much g increased by. From 2 to 6, g went up by 8 units. That's what we just found out. Now, here, from 6 to 8, g prime is negative, so g is decreasing. And that's why this area is negative, because this tells us how much g is decreasing by. G is actually decreasing by 4 units from 6 to 8. So from 2 to 6, g went up 8 units. And then from 6 to 8, it went down 4 units. And so we're at 4 there. All right. Hopefully that made a little sense. I think that me explaining makes more sense than just having a written explanation. So hopefully that helped.